The following set of data contains the results from an agility test in which fourth graders jumped from side to side across a set of parallel lines, counting the number of lines they clear in 30 seconds. We want to calculate the center of this thing, the mean and the median. We'll draw a histogram and a box plot and then answer some questions below. I've already entered my data in list 1, as you can see here. What I want to do is get some information about it. So I'm going to go to statistics, cursor one right to calculate, and we're going to want the one variable statistics for this one. My data is in list 1, so I'll enter list 1 and hit enter. X bar is the mean, which is 22.16. To get the median, we need to go down to the 5-number summary. So the median here is 22. We're going to draw a histogram for this one. We're going to actually ask the calculator to help us out a little bit. So we're going to go to our statistics plot, where we're going to make sure it's turned on. It is. We're going to go to the histogram, which is the upper right hand side. We also want to make sure our X list is the appropriate list. In this case we have our information entered in list 1, so we'll use list 1. The next thing we're going to do is hit zoom 9. And there's our box plot. Now you can hit trace and it's going to go through each one of these. So it seems like the maximum we need to have is 7 for a height, and then we need to go, let's see, from 14 to 16 and a half, and then all the way over here to 31.5. So let's see if we can do this one. We're going to start at 14. So we'll draw a vertical axis. We'll draw a horizontal axis. We're going to start here at 14. The next bar is at 16.5. We need to go to 1, 2, 3, 4, 5, 6, 7. Then be a 5, 4, 3, 2, 1. As we cursor through these, we can get the bottom scale as well. So you can just hit the trace button as we have already, and then just cursor to the right a little bit. The next one is going to be 19. As we cursor to the right, we can see it's 21.5. Notice how the difference between these numbers is staying the same. We're going to have another one here. I think that one's going to be at 24. Just double check. And then 26.5. The next one's going to be at 29 and 31.5. You can change these, they're called bin widths. Or ranges, but for now let's just grab what the calculator has. So I'm going to go back. The first one has an n value of 2, so we want to draw this one with a height of 2. If you want, you can put a little 2 there on top. The next one is going to be a height of 3, n is 3. And again, we can put the 3 there if we'd like. The next one has a height or a total of 4. And then the next one has that height of 7, all the way at the top. Next bar has a height of 5, a height of 3, and then a height of 1. To draw the box plot, we need to go back to our 5-number summary. So our 5-number summary here is minimum 14, Q1 is 19.5, the median is 22, Q3 is 25, and the max is 29. Let's see if we can draw this by hand. I'll make my scale starting at 10. We'll make this 20. So right here would be 15. Make that 25. And we've got 30 over here. To draw the box, we need to go to Q1, which is 19.5. Right in there. Q3 is 25. will make the box. The median is 22. The left whisker has an end or a minimum at 14. And the right whisker has an end or a maximum at 29. There's your box and whisker plot. You can also do this in the calculator. What we want to do now is answer some of these questions here at the bottom. We want to describe the shape of the distribution. If we look at either the box plot or the histogram, and I probably should have put some values here for you, the shape of the histogram is roughly symmetric. We can see here that the length of this whisker is approximately the same as this whisker. The median, while not directly in the middle, is pretty close to being in the middle. So we could say that this is symmetrical. We also want to talk about the modality. That's one thing you can't get from the box plot. You can get that from the histogram though, and it looks like it's unimodal, meaning that there's one hump, or one bump. We're also going to calculate the range in IQR. So for the range, we're going to take the maximum, which is 29, minus 14, which is the minimum, and that's going to be 15. For the IQR, we're going to work with Q3, which is 25, minus Q1, which is 19.5, and that's going to be 5.5. We're going to try to calculate the upper and lower fences and determine if there are any outliers for this one. So if we look at this, the upper fence is going to be Q3, which is 25, plus 1.5 times the IQR, which is 5.5. And I'll just type this in the calculator. So we've got 25 plus 1.5 times the IQR, which is 5.5, and that's 33.25. For the upper fence, we want to look at the data set and see if there's any values that are bigger than 33.25. We can see here that there's not. So for this one, there is no high outlier or one that's larger than the upper fence. We're going to now switch to the lower fence. Almost the same calculation, but we're going to start with Q1, and this time we'll subtract 1.5 times the IQR. So if I type that in the old calc here, we're going to get 11.25. If we look at our data, we're looking for any data that's lower than 11.25. We can see that we don't have any data that's lower than that. So we would conclude that there are no outliers. The next question asks us about the mean and the median. Remember from the previous part in part A, the mean was 22.16, the median was 22. So I'm going to say they're really close. This happens with symmetric data. If the data is not symmetric, then the mean will get pulled towards the skew or towards the outlier. One of the reasons we don't use the mean for skewed data. We're going to use the median for those. Which graph makes it easier to describe the shape? I think the histogram does. And the reason why is we can get both the symmetry and the modality from the histogram, but we can't get that from the box plot. So I'll say the histogram is easier. Box plot can't tell modality.